Hello, chemistry students. Today we are going to put all of the math we've been talking about this week to the test, and we're going to talk about a property of matter called density. Let's begin with a little exercise. Each of the blocks here are made of aluminum. Which one has the largest density? Okay, I hope you have your guess for that question. I'm going to point out some of the information that you can see on the screen about these blocks. I've written down the mass of each block, as well as the volume. Another important piece of information that you can see on this screen is that each of the blocks are made of aluminum. So they're made out of the same thing. Okay. Density is calculated by dividing an object's mass by its volume. Density equals mass over volume. This equation is a good one to have in your notes, so you could use it on a knowledge check. You could also write this equation out as capital D equals M over V. So I've given you all the information you need to calculate the densities of blocks A, B, and C. Density of block A is equal to 21.6 grams divided by 8.00 centimeters cubed. So dA equals 2.7. And I actually need 3 significant digits. So I'm going to add a 0 and then add my unit of grams per centimeter cubed. The density of block B is equal to 42.2 grams divided by 15.6 centimeters cubed. Okay, so my calculator gave me 2.704 grams per centimeter cubed. Now I can only have 3 significant digits, so I need to count those. 1, 2, 3. What does 4 do to 0? Nothing. So our final answer for density of block B is 2.70 grams per centimeter cubed. The density of block C is equal to 72.9 grams divided by 27.0 centimeters cubed. That is equal to 2.7, and I need 3 significant digits, so I'm going to add a 0, grams per centimeter cubed. Would you look at that? The density of block A is equal to the density of block B which is also equal to the density of block C. So none of them are more dense than the other. They're all the same. And this is what I expected because density is an intensive property. We're going to talk more about intensive properties next week, but I'll tell you today that an intensive property is a property that depends on the type of matter in the sample and not the amount of matter. So it doesn't matter how big your aluminum block is, it's still made out of aluminum, and aluminum still packs in the same way and has the same density. So if you add a larger volume, you will also add more mass, meaning that the density will stay the same, okay? Because density doesn't change based on how much or how little of something you have, density is a great way to identify what an object is made of. I've created these boxes at the bottom of the slide to give you another example of density. The little circles, those are supposed to represent atoms. So in green, we have a gas. Blue is supposed to represent a liquid. And I'm sure you can guess that the purple one is supposed to represent a solid. And just looking at these images, you can see that the properties of the atoms determine how much empty space is in the material. So solids will pack much more densely, and some solids pack denser than others. Some solids are made out of heavier atoms than others. So all of these things combine to make the density of that material. And densities of elements and common molecules are actually something that you can look up very easily. And if you have an unknown substance, you just need to measure the mass and volume of what you have, calculate the density, and then go ahead and look up that density in Google, and you will very likely find out what your unknown material is made out of. So let's practice some of those density calculations. All right, a copper penny has a mass of 3.1 grams and a volume of 0.35 centimeters cubed. What is the density of copper? We're going to use the equation we just learned. D equals M over V, which is equal to 3.1 grams divided by 0.35 centimeters cubed. I got 8.8571 grams per centimeter cubed. This number only has 2 significant digits, and this one also has 2, so my answer can only have 2 significant digits. What does 5 do to 8? Bumps it up by 1. So my final answer is 8.9 grams per centimeter cubed. What is the volume of an unknown substance that has a mass of 5.70 grams and a density of 2.3 grams per centimeter cubed? Okay, so the equation I gave you was D equals M over V. Okay, so let's manipulate this equation before we put the numbers in. I am going to multiply each side of the equation by V. So we're going to get dV equals M. And then I'm going to divide by density. So final equation is V equals M over D. Now I just have to plug mass and density into this equation. Those values were given in the problem. The mass is 5.70 grams. And our density is 2.30 grams per centimeter cubed. My calculator says the answer is 2.478. And our unit is going to be centimeters cubed because grams is on the top and the bottom of the fraction, and centimeters cubed is inverted, but it's also in the denominator. So that actually will flip it up, and our final unit is centimeters cubed. I need to edit my answer to have only 3 significant digits. 1, 2, 3. What does 8 do to 7? It will bump it up. Our final volume is 2.48 centimeters